First of all, I'd like to know what kind of people I've got in my audience, because I don't know what kind of operating systems you're all using. So I would like to do some fingerprinting of you. Oh, by the way, the slides don't look very spiffy, but I made them Thursday and I didn't have much time, so it's about the content, not about the way it looks. To find out what kind of operating system you are running, I would like to present you with some pictures, and then you will all boo or cheer or be silent, and I know what you're running. Okay, here we go. Huh? Who's that? Who the hell is that? Okay. Yeah. Is this a trick question? Okay, so my guess is nobody likes Microsoft, you all know Linux, and some of you do know FreeBSD. This was Bill Gates, of course. This is Ken Thompson. He was the guy who first started writing Unix. So in fact you're all running... Well, he's still alive, you know. Okay, this guy, he was the PR man of FreeBSD. This is Jordan Hubbard. He is also the release manager. He was the release manager for FreeBSD. Well, this is of course Linus. This is the mascot of FreeBSD. Well, in fact, it's the mascot of BSD. And this thing is a daemon. It's also sometimes called Chucky, but its real name is, I believe, Beastie. This guy you don't know is Marshall Kirk McCusick, and he wrote a lot of software for BSD, especially file system software. He's the inventor of the UFS file system, for instance. And of course, this is Tux. Oops. Okay, well, I like to talk a bit about the past because it's always nice to know a little bit about how Unix came alive to better understand why FreeBSD is what it is. As you may or may not know, Unix was started in 1969, 1970 by Ken Thompson and others. They were working at AT&T Bell Labs, and they wrote Unix on an old PDP system. And they made it open source. Why? Because they were in the middle of a split up. The AT&T was the big American telecom company, and they were having problems because they had a monopoly. So the American government said, okay, we're going to split you up into the Baby Bell corporations. Just like what's going to happen with Microsoft, Baby Bells. They had that in the 70s with the Baby Bells. And now they had a problem. They were not allowed to sell Unix because it was not a part of their core business. Their core business was telecom, and Unix was not telecom. So they couldn't sell Unix. So they gave it away for free. So that's how open source started. They gave away the source for free, but they kept the trademark on Unix. The name Unix was trademarked by AT&T. Through AT&T Unix, of course, they continued developing it, and it was a very stable operating system because it had to run in telecom stuff. And telecom systems can never shut down. They have to be very stable. So it was a very stable operating system, but a lot of companies got the source from AT&T and started building their own Unix, like, for instance, IBM. Turned it into AIX, and HP turned it into HPUX. And also Berkeley took it and made it BSD. They couldn't call it Unix because AT&T still had trademark Unix. By the way, now the trademark is in the hands of SCO. No, it was in the hands of SCO, which is now bought by Caldera. Caldera now has the official name Unix. Anyway, Berkeley also took the source and started building stuff into it. And they were a university, so they wanted to build in neat new stuff. So they had all these nice new neat features, but the system crashed every day. And AT&T Unix never crashed, but it was a very dull operating system. Well, they were very good with serial communications. And of course, those two main Unixes gave a lot of development stuff to each other. And one of the main things that was implemented on BSD was TCP/IP. The TCP/IP stack, the network stack, was first developed on BSD Unix. And that's of course why 80% of the systems on the internet are still running Unix. Internet was made great by Unix. And well, this is one of the pros of BSD. BSD has very stable networking code. The networking code is one of the oldest in all the Unixes that are around. It's very well debugged, very, very stable. Well, this is still BSD, not FreeBSD. So how do we get to FreeBSD? Well, the people of Berkeley University also kept improving BSD Unix. And there were some people who took the BSD source code and said we're going to port it to the Intel architecture and go from there. And they made it into 386 BSD. I don't know too much about 386 BSD, it didn't exist for very long. But then came a group who said we are going to take this BSD code and we're going to compile it on Intel only. We don't care about other platforms, Intel only, and we need it to be fast and user-friendly and super stable. But also there was a group, NetBSD, who said, well, actually we want to do the same thing, but we want to not limit ourselves to Intel platform. We want to have it running on every system imaginable. And NetBSD runs on your Sega Dreamcast and anything you have lying around. But they're a much more academic group of people. They don't care much that it is difficult to install. Well, it isn't that very difficult, but they rather put their effort in building new neat things than to make it very user-friendly to install. If you don't understand how to install it, don't start using BSD. The OpenBSD people also had the same motives, but they said, well, we want to really focus on security. OpenBSD is also multi-platform, also Intel, also other platforms, and they have a big focus on security. So I'm going to stick with FreeBSD, and first some non-technical things about FreeBSD, some aspects. And luckily I thought to myself when I was making the presentation, well, many people will probably know Linux, and you just proved me right. So I have some things that I compare FreeBSD with Linux. It's not to say that I say FreeBSD is much better than Linux, but just so you know what the differences are, right? So FreeBSD is a complete system. If you download FreeBSD, you get a kernel, you get all the utilities, you get everything that makes it a complete Unix system. It's not the case with Linux. Linux is a kernel, and to make it a complete system, you need utilities around it, and those are the Red Hats and the Mandrakes and the Slackware and what have you now. So, and that's why some people, like the GNU people, like to call Linux GNU Linux, because it's a Linux kernel with GNU stuff around it. So there are differences there are various kinds of Linuxes. While if you got FreeBSD, you've got the FreeBSD. There's only one. If you got Linux, you got the Linux kernel, but maybe a different distribution. How do you keep it one single entity? Because there is a core team of committers who closely watch the source code. The source code is stored in a big repository using the CVS program, the concurrent version system. There's a big repository of all the source code, and there's only a bunch of people who can actually make changes to that source code. It has advantages and disadvantages. The advantage is that the code that gets committed is tested very well. The people of FreeBSD try very hard, and also OpenBSD and NetBSD try very hard to get good code. It's better to have good code than to have code for new technologies fast. So the pro is, if my weird hardware is supported by FreeBSD, it works well. But if I buy the newest Matrox blah 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 video card, chances are it's not yet supported in FreeBSD because the code is not good enough to be committed. Ups and downs. And thank goodness FreeBSD isn't as popular as Linux, because it would have exploded, it would have died. If so many people, if the same amount of people that are contributing to Linux were contributing to FreeBSD, and all the changes would have had to gone through those core committers, it wouldn't have worked. So I'm really thankful that Linux is there, making the path for Unix. course, in Linux, the part of Linux, the kernel, is also closely watched by Linus Torvalds himself. It's about the same principle. Okay. Another difference between Linux and FreeBSD is the copyright. And not only the FreeBSD copyright, the BSD copyright is very, very loose. It basically says you can take the code, do whatever you want with it, as long as you say somewhere it's from BSD. And the difference with the GNU copyleft protection is that with GNU you cannot make changes to the code and not give them for free and then sell your stuff. With BSD you can. For instance, Nokia, they build their own firewall. It's a BSD system. They put on their firewall software and they can sell it. They don't have to put their own firewall software in the public domain. I still don't know if that's a good thing or a bad thing. But the fact is, that's how the licensing works. And also Wessel built an Interjet system, which is our ISDN dial-up router thingy, also runs FreeBSD. And Windows 2000, I'm sad to say, they also took a lot of BSD networking code, because BSD networking code is really great. And they can, because of the loose license. Sorry? You didn't know? Ah, yeah, well, the last line is getting a bit technical. You've got different, you have one repository of all the source code. But, so this source code progresses as people make changes. The latest version of the source code, the actual state of the repository at this moment, is called the current branch. That's the current code as it is now. And if I want, I can run the current code of FreeBSD on my system. Most of the time it's that good, that well developed, that I can just take today's code, put it on my laptop and run it. In fact, I'm running a version of a couple of weeks ago on my laptop. The code as it was exactly on that day. But sometimes people make big changes to the code and things will break. So current is considered bleeding edge technology. Only do it when you really have the need for it. Well, I happen to have a laptop with a weird Yamaha sound chip, which was only supported in the newest code. So that's why I run the current release. Then there's a stable branch. You can run stable code, which is code that is being tested. So changes to the code are being made in current. And if they're well enough tested, they go into the stable release. So you can also decide to keep up with the stable code. Or you can stick to the releases which come out every once so often. And those you can buy on the CDs. We're releasing what's nice about FreeBSD also is that you have those releases and you can easily upgrade as well. If I want to upgrade my system, I can give a command to connect to the main repository or a mirror of it and get all the new source code. So if I plan to upgrade my system, I give a command to fetch over the network the latest network FreeBSD code. All FreeBSD code, all the source code is on my system. It's about 400 megabytes. Then I can do a make of all the code. I will compile the complete system, not only the kernel, but every program that's on there, everything. That'll take 2 or 3 hours on this Pentium 3500. Then I install it, and it will install all the new binaries on top of my old binaries. And I have a complete upgrade. Well, not completely. I also need to change the configuration files, and there is a special tool to merge the new configuration files with the old ones. For instance, maybe somebody changed something in the etc host file, and you just don't want to put the new copy on top of the old one. You want to merge it with what you already had. Well, there's a tool for that as well. And it takes me about, well, 5 minutes to type those commands, 2 hours wait, get some coffee, do the merge tool, and I run a new version of the operating system. Merge master, right, that's the tool. And you can also do that for releases. So if I run release 4.1 and I want to upgrade to release 4.2, I fetch the 4.2 sources from the net, do the make, install all the new binaries, and I run release version 4.2. Yes? You can, but it's not very wise because you might run into problems. Yeah, you could do it, but you probably stick with the new programs that have been added, which are not removed. It might be tricky, but in theory it should work. So that's nice for instance, internet service providers who want to keep up with new releases, and you just have a minimum amount of effort to update to a new release. And, well, actually this is already my last slide, so I'll have to not talk too fast. Some features that hackers might like. It has some compatibility modes built in FreeBSD. It can run, and it's not emulation, it's compatibility. It can run Linux programs. If I take a Linux binary for Intel, I put it on this system, it will run most of the time. Almost anything will run, and I put it on the slide, even VMware, which I consider a very, well, dirty, I mean, it really digs into my system. It will run. The Linux binary of VMware, unaltered on my system, it will run. But of course, I need some Linux libraries, and there are some things in the kernel that make this all happen. But it works. And that's neat, because there are many more companies who make their programs for Linux than they do for FreeBSD. That's not a problem to me, because I just run the Linux binaries. Netscape, Flash, everything will run. Sometimes companies build a specific release for FreeBSD, like you can get an Oracle for FreeBSD or an Oracle for Linux. But if there's no port for BSD, I just run the Linux binary. And the same goes for BSD-OS, SEO, UnixWare, and Solaris, all three on Intel platform only. So if I have a Solaris on Intel program, I just copy over the Solaris libraries, shared libraries, it'll run. And well, this is a daring statement, speed up your Linux apps. I heard somebody once say that because the memory management of FreeBSD is in some cases better than that of Linux, faster, you can even get your programs to run faster, your Linux programs run faster on a BSD system than on a native Linux system. No? Well, the file system, that's something I really, really like. The file system is great. And that was made by this Kirk McCusick guy, who I had on the slide before, the guy with the suit. He did some really, really neat stuff in file systems. Way back when, with System 5 Unix, the file system was okay, but Kirk McCusick made some really great changes. He was working at the university. He built a new file system, which consists of building the file system software in the kernel, making a new UFS program to make a file system, a mount program, and well, actually you also need an FSCK, file system checker, but he never got around doing that. He just built this new file system, and he said to the supervisor, I built a new file system. So the supervisor said, well, if you want people to use it, you have to give the good example. Why don't you put your home directory on your newly written file system? So he said, oh, okay, I'll give it a shot. And it worked, until one day the system crashed, and then he had a problem because he didn't have an FSCK. So he spent 2 weeks writing an FSCK file system checker, and then he could work again. Phew. But that is the ultra-fast file system, UFS, that we still have in use today. And one of the latest newer developments have been soft updates. They were not invented by Kirk McCusick, but implemented by Kirk McCusick on the Berkeley file system. And I'm sure OpenBSD and NetBSD have them as well. Yeah? No. Soft updates, well, you can mount your file system asynchronous, which means whenever you write to disk, it's being put in a buffer cache in the memory, and the application gets to know of here's, okay, it's written to disk. Well, in fact, it is not. And when your system crashes, you lose all the stuff that's in the memory and has not yet been written to disk. Well, for an application it's bad, but not too bad. But if you were just writing a new directory or changing an inode on the disk, changing the disk layout, your file system may become screwed up beyond repair. Foobar, yeah, it's fast, but it's dangerous. And the other way of doing things is synchronous mounting. That means that you put everything in the buffer cache and wait until writing until you feel like it, except when you do things like making directories, removing directories, that sort of stuff. Which is very safe, but very slow. So if you took a Linux or FreeBSD system a few years ago, Linux would outperform FreeBSD. No problem with removing files. Because FreeBSD did all that stuff synchronously. But with the soft updates, it's a great trick in which the order in which the changes to the disk are being made are They are reordered in such a way that you can mathematically prove that your system will not go corrupt. So you get almost the speed of asynchronous writes, but you get the assurance of synchronous writes. So it's really great. My file system is now really fast. If I pull out the plug and put it back in again, in fact I can prove that the worst thing that can happen to my file system is that I am missing some free blocks. That means there are some free blocks on the disk, but they have not been marked as free. That's the worst that can happen. In fact, Kirk McCusick is now writing a background FSCK. Okay, so this means I've got 1 terabyte of disk, pull out the plug, put it back in. No FSCK needed. You just mount the disk. That's it. And the FSCK goes on in the background, fetching your lost blocks. Yeah. It's running on current. Okay, but it's development code. Yeah, it works? Great. Who needs NetApps? And I think you get, with the way your soft updates works, you also get snapshots, which is that you can freeze the file system. And that frozen image of the file system you can also mount or FSCK, or, more interesting, backup. Normally, if you're doing backups right, and I know most people don't, you don't back up a live file system. You have to unmount it before you back it up. Well, you can now just make a snapshot of a file system, and that's clean. You can FSCK it, you can back it up, and then throw it away. That's really neat. Oh, but one of the things I really like, I'm saying that a lot, am I? The ports collection. That's wonderful. That's one of the things that got most of my friends to use FreeBSD instead of Linux. Of those people who switched. I also know a lot of people who really like Linux a lot. The ports collection is a bit like the RPMs, but not quite. RPMs, you also have in FreeBSD, they're called packages, which is just a big tarball, you unpack it, that's it. The ports collection is a directory structure for a lot of programs, about 3,000. Can anybody read this? Oops. I got here a lot of categories. For instance, the category games. And here are a lot of games. Well, not the actual games are here, but just a skeleton. I have a makefile and some files describing this program. So this says this is xtux is a program, blah blah. And the makefile actually says where to fetch this program and how to compile it on the FreeBSD. And if this program needed to be patched on the FreeBSD, there would be patch files here as well. So this is just a couple of kilobytes. And if I type make here, I don't know if my Ethernet connection is working, but it will try to fetch it from the internet, apply patches, compile it, and install it. And there are 3,000 of these tools available. So if I want GIMP, I go to user ports graphics GIMP, I type in make install, the thing fetches it from the internet, applies patches, sees that it needs some other programs as well, PNG, stuff, PBM, gets those as well, installs it, ready. And the ports collection also works on the FreeBSD, under OpenBSD, and I don't know about NetBSD, and that's really really nice. And I don't seem to have network.
How is the ports collection kept in sync?
Kept in sync. There are volunteers who volunteer for a particular port. And I wasn't really telling the truth when I said that the whole FreeBSD system is being maintained by a couple of committers. That's right for the real core, but there are separate groups for the documentation with a lot of volunteers and the ports collection with a lot of volunteers. So if I volunteer to do the xtux port, I get access to the source repository for that particular port. And if I see that a new one is coming out, I'll change the makefile. And of course, with the CVS trick, I can get the new skeleton files from the internet as well. Okay, well, and I'm running out of time, so I have to be quick about things like stateful packet filtering. IP version 6 is all built in. In fact, all the things that you have in Linux, you also have in FreeBSD. There's a lot of overlap there. PicoBSD is a very small BSD on one floppy disk. You can make a router of one floppy disk. You can have a dial-in server on one floppy disk. and you can also make your own one floppy disk distributions, and I believe Linux has the same thing. Okay, well, the morale of this talk is I would like you to give FreeBSD a try. It's a nice operating system. You don't have to stick with it. If you like Linux better, that's okay. I'd say make love, not war. I'm not here to bash against Linux. I really want people to run different operating systems, because if the whole world runs one operating system, we're all vulnerable to the same bugs. So I'd say everybody take a different operating system, and if there are people who would really like to try FreeBSD, I got a couple of free 4.3 BSD install CDs, courtesy of Pete Shipley. Thank you. And I'll be handing those out, and you can give it a try. I don't know if I've got time for a quick question. No, haven't got time, so thank you.
Dat is wel cool, hè, van die networking code in Windows 2K.
Ja, beter help dan goed help dan
Ja, inderdaad. Staat wel klaar.